Good evening, guys. In the last class, we discussed about what is array list, linked list, vector, and stack. Array list, linked list, vector, stack classes are called list interface implementation classes. All are used to store group of objects. All classes will allow homogeneous values, heterogeneous values. They will allow null values, and the insertion order is preserved. All these are called collections classes, collections framework classes. These classes are implementing list interface. They are used to store group of objects. Insertion order they will maintain. Homogeneous, heterogeneous objects can be stored. Null values are allowed. Insertion order is preserved. Okay. Then after we discussed about what are the differences between these collection classes. Array list data structure is a groupable array. Linked list data structure is a double linked list. Vector data structure is a groupable array and it is a thread safe class, and it is also called as legacy class. Legacy class means legacy collection means the collections which are available from JDK 1.0, they are called as legacy. Next one is stack. Stack is a collection which is following LIFO, last in first out data structure. Stack is also a collection class implementing list interface, last in first out. And then after we discussed about cursors, there are three types of cursors available which are used to traverse the data from the collections. Iterator is one cursor, list iterator is one cursor, enumeration is one cursor. Iterator is cursor which will move in the forward direction. Iterator is applicable for list and set. That's why iterator is called as a universal cursor. It is applicable for list implementation classes as well as for set implementation classes. List iterator, it supports forward direction as well as backward direction for traversing. It supports only list implementation classes. List iterator can be used only for the list implementation classes. It is not applicable for the set implementation classes, whereas iterator is applicable for both list and set. Iterator is called as a universal cursor for a list implementation classes, and for set implementation classes also we can use that. For list implementation classes and for set implementation classes also we can use that. That is the reason it is called as universal cursor. Next one, enumeration. Enumeration supports forward direction and it supports only for legacy collection classes. Enumeration supports only legacy collection classes. So this is what we discussed in the last session. Are you clear? Are you clear? Perfect. Today we are going to talk about set category, guys. Today we are going to talk about set category. So what is a set? Set is also one interface. It is extending the properties from collection interface. Set is a interface available in java.util package. Set interface extending properties from collection interface. Set interface extending from collection interface. Set is used to store group of objects. Set is used to store group of objects. Duplicate objects are not allowed. Duplicate objects are not allowed. Not allowed. Homogeneous and heterogeneous supports homogeneous and heterogeneous values. Homogeneous and heterogeneous values can be supported. What is this set? Set is an interface available in java.util package. Set interface extending from collection interface. Set is used to store group of objects. Here duplicate objects are not allowed when we go for set interface. Duplicate objects are not allowed when we go for set interface. Supports homogeneous data as well as heterogeneous data. Set is a interface. Set interface having some implementation classes. Set interface implementation classes, guys. We cannot create the object for the set because it is an interface. What are the implementation classes available for the set interface? So there are several implementation classes available for the set interface. First one is has set. First one is has set. Second one is linked has set. Linked has set. Third one is a tree set. Like that, there are several implementation classes available in the set interface. Has set available, linked has set available, and a tree set available. Let us write one program on this sets. Right? Has set, linked has set, and a tree set. All are used to store group of objects. These are implementation classes of the set interface. These classes will not allow the duplicate objects. Let us see here what is going to happen when we use this set. We will talk about what is the internal data structure and how they are going to work. What is the internal data structure and how they are going to work. Hash table comes under map concept. All right. Now let us see here. Let us see here. I'm going to create one object has set. Has set is a predefined class which is available in java.util package. Java.util package. I'm taking some string. Has set is equal to hs is equal to new has set. I'm trying to store the data using has set. Has set dot add. I'm adding one object. One has set dot add of 2, has set dot add of 3, asset dot add of 3, and has set dot add of 4. I'm trying to add 4 objects in the has set. System dot out dot println of has set. I'm trying to add the objects and I'm trying to print this collection by using system dot out dot println. I'm printing. Guys, can you see these objects are inserted? Is it maintaining insertion order or it is not maintaining insertion order? When I go for a hash set, insertion order maintained or insertion order not maintained? Insertion order not maintained. Insertion order not maintained. Go to this hash set class implementing set interface. Now hash map internally hash set class is using a concept called hash map concept. What is the initial capacity of the hash set? The initial capacity of the hash set is 16 and the load factor of the hash set is 0.75. We'll talk about this. What is the initial capacity of the hash set and what is this load factor? This is a hash set class internally using hash map to store the objects. Now here I'm trying to store 1, 2, 3, 4. We'll talk about the internals. First, let's understand the basic functionality. Hash set dot add of 1. I'm trying to add the 1 once again. I'm trying to add the 1 once again. Let's observe this. 4, 1, 2, 3. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. I'm adding in the direction of 1, 2, 3, 4, 1. But are the objects are adding in the insertion order which I am adding? The insertion order is maintained. The insertion order is not maintained. Insertion order is not maintained. Duplicates are allowed. Duplicates are not allowed. Insertion order is not maintained. Duplicates order is allowed, or duplicates are not allowed. Duplicates are not allowed. Let me add hash set dot add of some null value. Some null value. Can I add a null value? Hash set dot add of null value. Is it accepting the null value? Yes, null value is also accepted. Null value is accepted. Duplicate objects are not accepted. And insertion order is also not maintained. Insertion order also not maintained. So let's note down some important points related to hash set class. What is this a hash set? Some important points. First one, implementation class for implementation class of set interface. What is a hash set? Hash set is the implementation class for set interface. Now here duplicates are not allowed. Duplicates are not allowed. Duplicates are not allowed. Null is allowed. Null is allowed. Insertion order will not be maintained. Insertion order will not be maintained. Hash set. Hash set is one implementation class for the set interface. Duplicate objects are not allowed. Duplicate objects are not allowed. Null object is allowed. Insertion order will not be maintained. Default capacity, initial capacity is 16. Initial capacity is 16. And load factor is 0.575. Load factor 0.75. Load factor 0.75. Implementation class of set interface. Duplicate objects are not allowed. Null is allowed. Insertion order will not be maintained. Initial capacity is 16. Load factor is 0.75. Now guys, you see here, whenever I am calling hs.add method, it is going to add the data in the hash set object add method. How this a hash set is maintaining the data internally? Hash set internally using a hash map concept. The initial capacity of the hash set is 16. The load factor is 0.75. 0.75. Okay, constructs a new set containing the element in the specified collection. Hash map is created with the default load factor. Initial capacity is sufficient to contain the elements in the specified collection. Now, what is the meaning of this hash set is whenever the internal data structure is hash table. Internal data structure is hash table. It is going to maintain a hash table internally to store the objects. Internal data structure hash table, load factor 0.75, initial capacity is 16, insertion order will not be maintained, null object is allowed, duplicate objects are not allowed. It is the implementation class of set interface. Now, whenever we create the object for the hash set, internally one hash table will be created. Internally one hash table will be created with the default capacity as 16. The nothing but 16 buckets will be created internally whenever we create the hash set object. 16 buckets will be created internally with a default capacity. Whenever I am creating hash set object like this, hash set hs is equal to new hash set. I'm creating the object. What is the default capacity of the hash set? 16. 1 to 16. Here 16 buckets will be created. Whenever we are calling hs.add method of some value like a 1, I'm storing one value like a 1. Whenever you call the add method, first it is going to check, is this object already available in the hash table? If the object is not available in the hash table, for this object it will identify the hash code. Based on the hash code, it is going to execute the formula. int bucket number is equal to some formula it will execute based on hash code of the object. It is going to execute some formula based on the hash code of the object. When this formula is executed, that formula will give the bucket number. Okay, here I'm calling hs.add of 1. 1 is the string object I'm adding to the hash set. What is the internal data structure of the hash set? Internally, it will maintain a hash table. Hash table will be created with a capacity of 16. 16 buckets will be created. Whenever you add one object, it will check what is the hash code of the object. Based on the hash code of the object, it will execute one complex formula. That formula will give what is the bucket number. If this bucket number will be given based on the size of the buckets. So total there are 16 buckets available. So this formula will return the bucket based on the bucket number. Based on this formula, bucket number will be returned. Now 1 is available. 1 is not available in this bucket, so assume that this has returned the bucket count as 1, then 1 will be stored here. Is there any guarantee that always it will store in the first bucket? No guarantee. It may store here also. 1 is stored here. Whenever you add this method, whenever you call the add method will return boolean value as a output. If the object is really added to the hash set, then it will return true as the output. If the object is already available, add method will return the false as the output. Okay, now here it is going to return the output as true because the object is not available in the hash table. This one object will be added to the hash table. It will return true as the output. Now again, when I call hash set dot add of 1, I'm trying to add the same object once again. Duplicate object. Whenever I execute a hash set of add 1, here it is going to check that with this content object 1, is there any object already available in the hash table? Yes, already there is an object available in the hash table, so this method is going to return false value. This object will not be added to the hash set because it is a duplicate object. It is a duplicate object. Now I'm going to call hash set dot add of 2. Hash set dot add of 2. Now whenever I call hash set dot add of 2, it is going to check in the hash table, is there any object available with the content as 2? There is no object available with the content to 2. Then what it will do? It will execute the formula based on the hash code of the object. That formula will return the bucket number. Assume that 2 has returned the bucket number 2. It is going to store in the second bucket or any bucket number. Whatever the bucket number we will get as output, our object will be stored into this bucket number. Then as the object is added to the hash set, it is going to return true as the output. When you add the object, if the object is not available in the hash table, it will identify the bucket number based on the hash code of the object. That object will be stored into the hash table internally. That add method will return true. When you try to add the same object again, it will check that this object is already available in the bucket. Yes, it is already available in the bucket, so don't add it. Duplicates are not allowed. It is going to return false value. When you add the another object, it will check in the hash table that object is not available, so it is going to find out the bucket number to store the data. Suppose assume that when I add the 2, the bucket number coming as a last bucket, 16th bucket, 2 will be stored here. 2 will be stored here if it is not available. If it is available, it will not add it. Now, do you understand that? Do you understand that how hash set is working internally? What is a hash set? It is the implementation class of set interface. Duplicate objects are not allowed. Null is allowed. Insertion order will not be maintained. Initial capacity is 16. Load factor is 0.75. Internal data structure is a hash table. Now, what is this load factors are 0.75. Now in the 16 buckets are available for the hash set, right? Once 0.75% of the buckets are completed, then the new hash table will be created. The default capacity is 16. What is the load factor? Load factor is 0.75. What is the meaning of that? Once 0.75% of the hash table is filled with the objects, then it is going to create the new hash table with the latest capacity by copying the existing objects. New hash table will be created once your hash table data is reached to 0.75 capacity. 0.75 capacity. Understood? Now, internal data structure is a hash map. That a hash map will internally use the hash table. Internal data structure is a hash table. It will use a hash map to store the data. So whenever you add the object in the hash set, your object will be added as a key in the hash map. Your object will be added as a key in the hash map. Duplicates are not allowed. Duplicates are not allowed. Okay. Now here, can we remove the object from the hash set? Hash set dot remove the particular object. Hash set dot remove the particular object. I want to remove the object 3. I want to remove the object 3. System dot out dot println of a hash set. Now here I'm printing the hash set. Here I'm removing the object. Here I'm printing the hash set. See the reference. Now null is there, 4 1 2 3. I have removed 3, 4 1 2 is available. Insertion order is maintained. Insertion order is not maintained. Insertion order is maintained or insertion order is not maintained. Insertion order is not maintained. Not maintained. Duplicates are accepted. Duplicates are not accepted. Is it accepting the duplicates or it is not accepting the duplicates? Duplicates are not accepted. Null values are accepted or null values are not accepted. Null values also accepted. What is the initial capacity of the hash set? 16. What is the load factor of the hash set? 0.75. What is the meaning of load factor? What is the meaning of load factor? Once 75% completed, new hash set object will be created internally by copying the old data. By copying the old data. Yes, null will be allowed only one time now. Duplicate will not be accepted. Okay, here instead of creating the hash set with the default capacity, can we create the hash set object with our own capacity and our own load factor? Can we create the hash set object with our own capacity as 100, our own load factor as a 10.05, something like this, as a float value? Can we create our own? Can we create the hash set object with our own capacity and our own load factor? Yes, we can do that. Default capacity is 16, default load factor is 0.75. We can create the object with our own capacity and our own load factor. That is a parameterized constructor. That is a parameterized constructor. So here constructors available. Here constructors available. You can go for hash set HS is equal to new hash set default. You can go for a hash set HS is equal to new hash set of just int capacity. Int capacity. You can go for a hash set HS is equal to new hash set of int capacity comma float load factor. Float load factor. Like this, you can also do this. You can create the hash set with the default constructor. You can create the hash set with your own capacity. You can create the hash set with your own capacity and load factor as well. Okay guys, implementation class of set interface, duplicate objects are not allowed, null is allowed. Insertion order will not be maintained because it is storing the data based on the bucket number. The data will be stored in the buckets. How it will identify the bucket number? Bucket number will be identified based on the hash code of the object which we are storing. How it will maintain the objects internally? Internally it will maintain a map concept in the form of key value. So whatever the objects you are storing in the hash set, they will be stored in the form of keys in the hash map. Hash set internally uses a hash map to store the data in the form of keys. Keys. Are you clear? Can I iterate the hash set by using iterator? Iterator is applicable for hash set or iterator is not applicable for the set classes? Can I use list iterator for the hash set? Can I use list iterator for the hash set? See here, hash set dot iterator method. Iterator is available. I'm getting the iterator object. While iterator dot has next. Now I am going for system dot out dot println iterator dot next method. I'm going to get the data. I'm going to get the data. Null value 421 is available. I'm able to use the iterator. Am I able to use the list iterator? Do I have any method called list iterator here, guys? List iterator is available for this set implementation class. List iterator is not available for the set implementation class. List iterator is not available for the set implementation class. List iterator is available only for the list implementation classes. Iterator can be used for the list implementation classes as well as for the set implementation classes. That's why iterator is called as universal cursor. Iterator is called as universal cursor. Are you clear? Are you clear with this? Now, instead of storing these objects, can I store student objects into hash set? Can I store custom objects into hash set, guys? Here I'm storing normal objects into hash set. Similar to this, can I store user defined objects into hash set class? Can I store user defined objects into hash set class? I'm going to create the hash set object. I'm going to create a hash set object. Hash set, I'm going to specify student. Hash set is equal to new hash set. Hash set is equal to new hash set. Now hs.add of new student 101 comma some Raju. Now hs.add of new student of some 102 comma some Rani. Use student ID, student name. Hash set dot add of new student 103 comma some John. Now I want to print this data. You can print by using for loop. You can print by using for each loop. You can print by using cursor. Hash set dot iterator. It is a cursor. While iterator dot has next. Then system.out.println iterator dot next. I'm printing. Okay, guys. So objects will be printed in the same order. How I have inserted 101, 102, 103. Will it maintain the insertion order or it will not maintain the insertion order? Will it maintain the insertion order? Will not maintain the insertion order? Will not maintain the insertion order. Run this program. Oh, see here, 103 added in the first place, 101 added in the middle, 102 added in the last position. So insertion order is maintained or insertion order is not maintained? Insertion order not maintained. Insertion order maintained or insertion order not maintained? Insertion order not maintained. Insertion order not maintained. Okay, guys, fine. So we are able to add normal objects in the hash set, I mean string objects, and we are able to add user defined objects also in the hash set. With this, are you guys able to understand what is a hash set and how it is working internally? Are you guys able to understand what is a hash set and how it is working internally? What is the internal data structure of the hash set? What is internal data structure of the hash set? The internal data structure of the hash set is a hash table. Hash table. What is load factor? What is load factor? What is the purpose of load factor? What is the purpose of load factor? When the new hash set object should be created. When the new hash set object should be created. So the default capacity is 16. Once 75% of the hash set is completed, it will create the new hash set by copying the old data. By copying the old data. All right. Next one. There is another class available which is called linked hash set. There is another class available which is called linked hash set. Linked hash set implementation class for set interface. Implementation class for set interface. Duplicates are not allowed. Duplicates are not allowed. Insertion order will be maintained. Hash set will not maintain the insertion order, whereas linked hash set will maintain the insertion order. Internal data structure is hash table plus double linked list. Hash table plus double linked list is the data structure for the linked hash set. Implementation class for the set interface, duplicates are not allowed. Insertion order will be preserved. Internal data structure is double linked list concept. Double linked list concept. Okay, guys. Now let me go for linked hash set example. Here linked hash set I'm taking. Linked hash set. Let me take some integer. Linked hash set is equal to new linked hash set. New linked hash set. Linked hash set dot add of 10. Linked hash set dot add of 20. Linked hash set dot add of 30. Add of 30. Linked hash set dot add of null value. Linked hash set dot add of 40. That's it. System dot out dot println of linked hash set. Here I'm adding linked hash set dot add of 20 again. I'm trying to add the null value. I'm trying to add the duplicate value. Check this. What is the behavior? What is the behavior? Run this program. Can you see this, guys? When we go for linked hash set, insertion order maintained. Linked hash set maintaining the insertion order or not? Yes. As we discussed yesterday, linked list. Double linked list concept will be available for the linked hash set. Double linked list concept will be available for the linked hash set. Duplicates are allowed, duplicates are not allowed. Duplicates are not allowed. Insertion order maintained or insertion order not maintained? Insertion order maintained or insertion order not maintained? Insertion order maintained. Insertion order maintained. Insertion order maintained. This is linked hash set. Is there any initial capacity for this? Is there any load factor for this? When you go for linked hash set, is there any initial capacity? Is there any load factor for this one? Say this. Is there initial capacity? Is there any load factor? Hash table and linked list implementation of the set interface with the predictable iteration order. The implementation differs from a hash set in that it maintains a double linked list running through all of the entries. The internal data structure is a double linked list. The internal data structure is a double linked list. Double linked list. Got it. It is available from 1.4. Available from 1.4. Hash set. Linked hash set. Construct a new empty linked hash set with the default initial capacity 16, load factor 0.5. For linked hash set also, what is the capacity? 16. What is the load factor? 0.75. 0.75. Linked hash set. Initial capacity 16. Initial capacity 16. And what is load factor? Load factor is 0.75. Sir, then what is the difference between hash set and linked hash set? What is the difference between hash set and linked hash set? Both are almost same. The only difference is insertion order. Hash set will not maintain the insertion order. Linked hash set will maintain the insertion order. Hash set will use a hash table as a data structure. Linked hash set will use a double linked list as a data structure. Double linked list as a data structure. Able to understand? Good. Linked hash set and a hash set. Hash set and linked hash set both are the set implementation classes. Duplicates allowed in the both classes. Insertion order is preserved. Insertion order is preserved only in the linked hash set. Hash set will not preserve the insertion order. Internal data structure for a hash set is just a hash table. For linked list, internal data structure is a hash table plus double linked list. Initial capacity is 16. Load factor is 0.75. The difference between hash set and linked hash set is hash set will not maintain the insertion order. Linked hash set will maintain the insertion order. Hash set will not maintain insertion order, whereas linked hash set will maintain insertion order. Hash set will not maintain the insertion order, whereas linked hash set will maintain the insertion order. Load factor, initial capacity is same. Data structure is also different. Hash set will follow hash table data structure. Hash set will follow hash table data structure, whereas linked hash set will follow hash table plus double linked list data structure. Hash set will not maintain the insertion order, whereas linked hash set will maintain insertion order. Hash set will follow hash table data structure, whereas linked hash set will follow hash table plus double linked list data structure. Are you clear? Now here if you go to set interface, now here we have hash set. Here we have hash set, and here we have linked hash set, and here we have tree set. These three classes are implementation for set interface. Set is one interface extending from the collection. Linked hash set and tree set. Now hash set implementing set interface, linked hash set implementing set interface, tree set implementing set interface. Now hash set, linked hash set both are almost same. No insertion order. Okay, if you go for a hash set, no insertion order. Here it will maintain insertion order. Here duplicates are allowed both places. Allowed or not allowed? Duplicates not allowed. In the both places, duplicates are not allowed. Null allowed. Capacity 16 default. Load factor 0.75. Then data structure. It will follow hash table as a data structure. It will follow hash table plus double linked list. As a data structure. That is for set and linked hash set. Coming to tree set, it is very special, guys. Tree set is very special. Now when we are going for a tree set, right, tree set will maintain sorting order, not insertion order. Tree set will maintain sorting order. Internal data structure is binary tree. Null not allowed. So whenever you go for the tree set, tree set will maintain the data in the natural sorting order. Whenever you insert the data in the tree set, by default it will sort the data by using natural sorting order, and the tree set will follow binary tree concept. Here, null objects are not allowed. I will tell you why null objects are not allowed in the tree set. Let me go to tree set concept. Let me go to tree set concept. Here I'm going to create a tree set object. Here I'm going to create a tree set object. And one more thing is, guys, in the tree set, only homogeneous values. In the tree set, only homogeneous. All the remaining collections will support both the homogeneous values and heterogeneous values. But a tree set is a special class which will allow only homogeneous values. Why it will allow the homogeneous values? Why null values are not allowed? We will understand that. I'm going for a tree set. Tree set to TS is equal to new tree set. Tree set to TS is equal to new tree set. TS dot add of 13. Okay. TS dot add of 7. TS dot add of 9. Okay. TS dot add of 1. 1. TS dot add of 3. Now system dot out dot println of TS. I created a tree set object and I'm adding some data in the tree set object and I'm printing the tree set object. Let's execute it. Guys, is it maintaining insertion order or it is maintaining a sorting order? My objects are maintained in the insertion order. My objects are maintained in the sorted order. My objects are maintained in the insertion order. My objects are inserted in the sorted order. Sorted order. What is the sorted order? Natural sorting. Ascending order. Ascending order. Now here, can I say I have added only numbers? I have added only numbers. Now here I am trying to add tree set dot add of high. Tree set dot add of high. I'm trying to add the tree set dot add of high. I'm trying to add homogeneous data and heterogeneous data. Verify this. Is it accepting the heterogeneous data or it is not accepting the heterogeneous data? Is it accepting the heterogeneous data or it is not accepting the heterogeneous data? It is not accepting the heterogeneous data. Why it is not accepting the heterogeneous data? The reason is tree set will follow natural sorting order. Now, first, if you store first object as an integer, you need to store the remaining objects also as an integer. If you store the first object as a string, you need to store the remaining objects also as a string. If you see first object, I'm going to store it as a Raja. And the second object I'm going to store as Ganesh. Third object I'm going to store as Ashok. Raja, Ganesh and Ashok. Now let's execute it. See, in the alphabetical order they sorted. Ashok, A is first character. It will come in the first position. G, Ganesh will come in the second position. R, Raja coming in the third position. Can I say my names are sorted in the alphabetical order? Can I say my names are sorted in the alphabetical order? When I add the numbers, numbers are sorted in the ascending order. When I add the strings, they are sorted in the alphabetical order. They are sorted in the alphabetical order. So here, can I say that tree set will follow natural sorting order? If you go for the numbers, numbers will be sorted in the ascending order. If you go for the strings, strings will be sorted in the alphabetical order. Tree set will follow by default natural sorting order. The internal data structure for the tree set is a binary tree. Null values are not allowed. Homogeneous values only it will accept. Sir, collections means heterogeneous na? Collections means heterogeneous na? In the hash set, I am able to store the homogeneous data and heterogeneous data. In the linked hash set also, I am able to have the homogeneous data, heterogeneous data. But in the tree set, why homogeneous data? In the tree set, it will accept only homogeneous data. The reason is internally it will follow natural sorting order. Whenever you add the object to the tree set to TS is equal to new tree set. Tree set TS is equal to new tree set. I'm creating object for the tree set. What is the tree set meaning of that? Tree set meaning of that is tree set will follow natural sorting order. Whenever we add the first object, you can add first object as anything. First object can be a number, or first object can be a string, first object can be a name also. TS dot add. I have added. When I add the first object, it is going to create a tree. It is going to create a tree. It will maintain the 10 in the tree. It will maintain the 10 in the tree. Okay. Whenever you add ts dot add of 5, ts dot add of 5. Now, whenever you add the second object in the tree set, tree set will compare this second object with the first object. Array, already one object available in the tree, and again second object came. It will compare this second object and first object. It will compare the second object and first object. First object is a number. If a second object is also number, then only it can compare the second object with the first object. 5 and 10 is available. Array, 5 is a lower value, 10 is a bigger value. That means 5 should be available in the first position, 10 should be available in the next position. Ascending order. It is going to store that. Now again, whenever you add a ts dot add of 3, ts dot add of 3, it will compare this 3 with the previous value. 3 will be compared with the previous value. If you add all the numbers, it will compare the numbers and it will sort them. For example, first 3 numbers I have added as a numbers, and fourth value I have added ts dot add of high. Where this high should come? It will compare the current object with the previous object. Previous object is a number, current object is a string. Comparison is not possible. That's why it is going to give you class cast exception when you add the homogeneous data in the tree set. It will give you class cast exception. First object you added as a number, second object you added as a number. It will compare which object should come first. Then you added third object also as a number. Your third object will be compared with the second object, which should come. Fourth object, if you add a number, no problem, it can compare. But fourth object you added as a string. String will be compared with the integer. Comparison will fail. Why it is comparing? Because the default implementation, tree set should maintain natural sorting order. Tree set should maintain natural sorting order. That's why whenever you add one object, your object will be compared with the previous object and it will decide the order, natural sorting order. I have added all the strings. Now I am adding ts dot add of 10. 10 is a number. Previous object is a string. Current object is a number. Comparison will fail. That's why you are going to get the exception, class cast exception. Boss, java.lang.string cannot be cast to java.lang.integer. I have all the remaining objects as string. This object you are adding as a number. This number I cannot convert to the string to compare. That's why it will fail. If you want something, you have to lose something. If you want something, you have to lose something. If you want the natural sorting order, then you need to lose the homogeneous feature. So whenever you want to sort the data, whenever you want to store the data, in the natural sorting order, then you will go for the tree set concept. What is the internal data structure of the tree set? Tree set will internally maintains binary tree to store the data. Tree set will maintain binary tree to store the data. So we are talking about tree set. Guys, now do you understand why tree set is accepting only homogeneous values? Why not heterogeneous values? Why tree set is using only homogeneous values? Why it is accepting only homogeneous? Why not heterogeneous? Why not heterogeneous? Because of sorting technique. Internally it is implemented with the sorting. If two objects are of the same type, then only we can compare, na? If two objects are belongs to same data type, then only we can compare, na? Can I compare a bike with a car? You can compare Benz car with a BMW car. Car should be compared with the car only. Can you compare Benz car with a Pulsar bike? Is that comparison valid? Is that comparison valid? Comparing a car with a bike? No. Comparison should be there for the equal type of objects. Always you need to compare equal type of objects. Always you need to compare equal type of objects. If you add the first object as a string object, all the remaining objects also should be string only. Then only it can compare to maintain the natural sorting order. To maintain the natural sorting order. If you add one string object, one integer object, then how it will compare this? Tree set means it has to maintain the sorting order. Java people made that tree set means a natural sorting order. Tree set is available from 1.2. Available from 1.2. Okay. A navigable set implementation based on the tree map. The elements are ordered using their comparable natural ordering by using comparator. Provided at a set certain time depending on which constructor to use. Note that the ordering implemented by a set must be consistent with the equal if it is to be correctly implement the interface. Right? Note that implementation is not synchronized. If multiple threads access tree set concurrently, at least one of thread modifies the tree set. The type of maintained by this tree set. What is the internal data structure? Tree. It is internally using tree map. Tree map it is using internally. This tree set is internally using tree map concept. See here, whenever you create the object for the tree set, internally it is creating the object for the tree map. So to understand the set concepts clearly, we need to understand the map concept. List set map. To understand the set concept, first you need to understand the map clearly. Okay guys, tree set is following the natural sorting order. Sir, I don't want to follow the natural sorting order. Can I customize the sorting order? Yes, you can customize the sorting order. I will come to that. First, we need to understand the basic concept of the collection. Then we will see real-time use cases. Then we will see how to sort the collections, how to customize the sorting. We will discuss that. Clear, guys? Are you able to understand? Why tree set is supporting only homogeneous data? Why not heterogeneous data? Other collections are supporting the homogeneous data and heterogeneous data, but tree set is supporting only homogeneous data. Tree set means natural sorting order. Data structure is a binary tree. Null values are not allowed. Null value is not allowed. Why? In the earlier collections, null values are allowed. In the tree set, null value is not allowed. Why null value not allowed? If you compare null value with any other object, you will get the null pointer exception. That's why null objects are not allowed in the tree set. First object is Raja. It is a string value. Second object should be string. Third object should be string only. Suppose if I add Raja and null. Now see what will happen. Null pointer exception. It is comparing null value with the Raja. Always whenever you add the object to the tree set, a tree set will try to compare the current object with the previous object. First object is Raja, second object is null. Null is comparing with Raja. Null pointer exception. Null pointer exception. If I go for the duplicate data, will it accept duplicate data or will not accept duplicate data? Tree set will accept duplicate data or tree set will not accept duplicate data. TS dot add of some Rani. All are the string objects only. Raja, Raja, Rani. What will come now? Raja, Rani. Duplicates are allowed or duplicates are not allowed? Duplicates are not allowed. Why? Because it is a set implementation class. In the set implementation class, duplicates are not allowed. In the set implementation classes, duplicates are not allowed. So tree set is a special class. Sorting order will be maintained. Heterogeneous data not accepted. Null also not accepted when you go for a tree set. You understand why null is not allowed? You understand why null is not allowed? You understand why heterogeneous is not allowed? You understand why heterogeneous is not allowed? Why heterogeneous is not allowed? Because it has to maintain the sorting. To maintain the sorting, every object should be compared with the previous object. Every object should be compared with the previous object. As it has to compare every object with the previous object, as it is going to compare every object with the previous object, data type should be same. When you add the null value, when you compare null object with the other object, you will get the null pointer exception. I have shown you. Rakesh Kumar, are you sleeping? Why null is not allowed? I already told you. Whenever you add a null value will be compared with the previous object. Then it will give you null pointer exception. Which sorting algorithm it is using? Default natural sorting order. Default natural sorting order. How it is doing that sorting? In the Java, there is a concept called comparator. There is a concept called comparator. It is using internally a concept called comparator in order to perform the sorting. See here, tree set will take the comparator. Comparator is a functional interface available in the java.util package. We are going to talk about what is a comparator and what is a comparable. We will talk about them. Comparator and comparable. We'll discuss in the sorting techniques. Right. Let me note down the points about the tree set. Let me note down the points about the tree set. What is the tree set? Implementation class for set interface. Implementation class for set interface. It will maintain natural sorting order. It will maintain natural sorting order. Tree set, implementation class for set interface. Tree set will maintain natural sorting order. Duplicates are allowed or duplicates are not allowed? Duplicates are not allowed. Duplicates are not allowed. Duplicates are not allowed. Insertion order will be maintained or sorting order will be maintained? Insertion order will not be maintained. Sorting order will be maintained. Tree set is the implementation class of the set interface. It will maintain natural sorting order. Duplicates are not allowed. Duplicates are not allowed. Null values are not allowed. Null values are not allowed. It supports only homogeneous data. It supports only homogeneous data. Why it is supporting only homogeneous data? Why it supports only homogeneous data? Tree set should perform sorting. Tree set should perform sorting when we add the object. Tree set should perform the sorting. So always it will compare new added object with old object. In order to compare, objects should be of same type. Object should be of same type. That's why it is accepting only homogeneous data. What is a tree set? Tree set is the implementation class for set interface. It will maintain natural sorting order. Duplicates are not allowed. Null values are not allowed. Why null values are not allowed? When we add a null value, it will compare null value with the previous object, then we will get null pointer exception. When we add a null value, it will try to compare null value with the previous object. Null object with the previous object, then we will get null pointer exception. That's why we are not going to add the null value in the tree set. Tree set is the implementation class for set interface. Tree set will maintain the natural sorting order. Duplicates are not allowed in the tree set. Null values are not allowed in the tree set. When we add null value, it will try to compare null value with the previous object. Then we will get null pointer exception. Tree set supports only homogeneous data. Why it is supporting only homogeneous data? Tree set should perform sorting. So always it will compare newly added object with the old existing object. Always it will compare newly added object with old object. In order to compare the objects should be of same type. Otherwise we will get a class cast exception. class cast exception. Tree set is a special collection, guys. It will maintain the natural sorting order. What is the internal data structure? Internal data structure is a binary tree. Internal data structure is a binary tree. Internal data structure is a binary tree. This tree set will internally uses a tree map concept. That tree map concept will use binary tree. So all the set based collections depends on the map. Set based collections are depends on the map, guys. Set based collections are depends on the map concept. Okay. Are you clear with the tree set now? Are you clear with the set based collections? Hash set, linked hash set, tree set. Hash set, linked hash set, and tree set. Hash set, linked hash set almost same. Hash set will not maintain the insertion order, whereas linked hash set will maintain the insertion order. Hash set will maintain the data structure as a hash table. Linked hash set will maintain the data structure as a hash table plus double linked list. Tree set is a special collection. Whenever we add the objects, tree set will maintain the natural sorting order. In order to maintain the natural sorting order, tree set will compare the newly added object with the old object. As it has to perform the comparison, it supports only homogeneous data. If you store the heterogeneous data, it will give class cast exception. What is the internal data structure of the tree set? The internal data structure of the tree set is binary tree. Why null values are allowed in the other collections? Why null values are not allowed in the tree set? When you add a null value in the tree set, it will compare null value with the previous object. So now I have added Raja and Raja. So here what will happen? Raja is available, Rani is available. First object Raja will be stored. Then second Raja already available. So it is a duplicate object. It will not be added. Then we will go for Rani. Rani is a string object. Raja is also string object. It will compare Raja and Rani. Alphabetically, which one should come first? Alphabetically, Raja should come. R-A-J, R-A-N. J comes before N. So Raja should come first, then Rani should come. It is going to compare the Raja and Rani. Alphabetically, Raja should come. Suppose, for example, if I add the Anil here, ts dot add of some Anil or Ashok. If I add the Ashok alphabetically, which one will come first? Ashok should come first alphabetically. Ashok is coming in the first position. So it is going to take Raja. Duplicate is not allowed. Second Raja will not be added. Only first Raja will be added. Rani. Raja and Rani will compare. Raja only should come first because alphabetically R-A-J will come first when compared with R-A-N. Okay, Raja is there, Rani is there. When you add the Ashok, alphabetically A comes first. So Ashok will be added first position. Raja will be in the second position. Rani will be in the third position. Ashok, Raja, Rani. Yes, three objects are there. Natural sorting order. Now, when I add ts dot add of null, what it will do? It will compare null value with the previous value. When you compare null value with the previous value, you will get a null pointer exception. See here, we are getting null pointer exception. That's why null values are not accepted in the tree set. Null values are not accepted in the tree set. Clear, guys? Now here, when I execute this program, output will be Ashok, Raja, and Rani. It is maintaining the natural sorting order. Sir, can we customize the sorting order? I don't want to go for the natural sorting order. I want the reverse of alphabetical order. I want to reverse it. Can we customize the sorting order? Yes, there is a concept called comparator. By using comparator, we can do the sorting. By using comparator, we can do the sorting. How to do the sortings? That I will discuss once we complete the map concept. Once we complete the map concept, then I will discuss that sorting techniques, comparator, comparable, what is a natural sorting order, what is a customized sorting order, that also we are going to understand. Are you clear with the tree set concept? Are you guys clear with the tree set concept? What is a tree set and how to work with the tree set? Yes. Now, when I go for a tree set, can I go for iterator? When I go for a tree set, can I go for iterator? Iterator is supported or not supported? Supported. Iterator supported. Now, while iterator dot has next, iterator dot has next, system dot out dot println iterator dot next, iterator dot next. When I execute it, see, we are able to access. Can I go for list iterator? Can I use a list iterator? List iterator supported or not supported? List iterator not supported. Why list iterator not supported? Guys, why list iterator not supported? List iterate supports only list collection classes. Tree set is a set collection class. Tree set is a set based collection. List iterator supports only list based collections. List based collections. Okay, guys. Understood? Guys, we are understanding the basic concept, where to use in the real time, how to do the sorting. These things we will discuss. First, let me complete. So now, without having the complete knowledge on the map concept, can you understand the set concepts? Whenever you create the tree set object with the zero param constructor, now I am creating tree set. When I'm creating the tree set, do you know what is happening in the background? A map is creating. What is the map? We don't know. So without having the knowledge on the map, can you get the clarity on the set? Without having the knowledge on the map, will you get the clarity on the set? No, because set based collections are internally using the map concepts only. First, let me tell you the map. Once we understand the map, then we will come back to the set and we will understand the set internals clearly with the custom sorting techniques also. Today is not the last class. Today is not the last class. Next week also we are going to work on the collections only. Once the map is completed, then I will come to the real-time scenario. Where to use list, where to use set, where to use map, how to work with them, how to do the custom sorting, how to do the natural sorting, all those things. Okay. So first we are understanding the concept. Once you are clear with the concept, we will go for the real-time scenarios also. Without having the concept clarity, how you will understand real-time scenario? So with this we understood list based collections and set based collections. Can I say we completed list based collections and set based collections? List based collections and set based collections. In the list based collections, what we have? We have array list and we have linked list and we have vector and we have stack. List based, array list, linked list, vector and stack. Okay guys, in the list based collections, functionality is almost same, just data structure is different. Functionality is almost same, data structure is different. All objects will, these things will maintain the insertion order. Duplicates are allowed, null values are allowed, insertion order will be preserved. All these things will be there in the list. When it comes to the set, what we have seen in the set based collections, we have seen a hash set and we have seen linked hash set and we have seen tree set and we have seen tree set. Hash set will not maintain the insertion order. Linked hash set will maintain the insertion order. Tree set will maintain the sorting order. All the collections will accept homogeneous and heterogeneous. Only tree set will maintain only homogeneous data. Why other collections are supporting homogeneous and heterogeneous? Why tree set is not supporting for homogeneous and heterogeneous? Why tree set not supporting for heterogeneous data? Why tree set is not supporting for heterogeneous data? Tree set has to maintain the sorted order. In order to sort the objects, it has to compare the objects. In order to compare the objects should be same type. In order to compare the objects should be of same type. The objects should be of same type. So that's why only homogeneous data accepted. Why tree set is not accepting null value? Why tree set is not accepting null value? Why tree set is not accepting null value? Whenever you add a null value means null pointer exception. Null value means null pointer exception. Clear, guys? Are you able to understand this? What is the internal data structure of the array list? What is the internal data structure of the array list? Growable array. Internal data structure of the array list is growable array. So now here we have array list class. Here we are having linked list class. Linked list class. Here we are having vector. Here we are having vector. Here we are having stack. Here we are having stack. Here we are having hash set. Here we are having linked hash set. Linked hash set. And here we are having tree set. We are having tree set. Tree set. Now, when we compare this, first one is duplicates. Duplicates. Insertion order. Insert order. Okay. Null value. Null value. Capacity. Capacity. Load factor. Capacity and load factor. Duplicates, insertion order, null value, capacity, load factor, and here data structure. What is the internal data structure they are going to follow? Now, when it comes to the array list class, duplicates are allowed in the array list. Duplicates are not allowed in the array list class. When it comes to the array list class, duplicates are allowed or duplicates are not allowed in the array list class? Guys, can you tell me duplicates are allowed in the array list class? Duplicates are not allowed in the array list class? Come on. Duplicates are allowed in the array list or duplicates are not allowed in the array list? Duplicates are allowed in the array list class. Duplicates are allowed in the linked list or not? Allowed. Duplicates are allowed in the vector or not? Allowed. Allowed. Duplicates are allowed in the stack or not? Allowed. Duplicates are allowed in the hash set? Not allowed. Duplicates are allowed in the linked hash set? Not allowed. Duplicates are allowed in the tree set? Not allowed. Insertion order. Array list will maintain the insertion order or not? Array list will maintain the insertion order. Linked has set, linked list will maintain the insertion order or not? Linked list will maintain. Vector also will maintain. Stack also will maintain. Has set will not maintain. Trees linked has set will maintain. Tree set will not maintain. Null value accepted in the linked list. Array list also will accept it. Vector also will accept it. Stack also will accept it. Has set will accept it. Linked has set will accept it. Tree set will not accept it. Tree set will not accept it. Data structure. What is the internal data structure of the array list? Array concept. What is the data structure of the linked list? Double linked list. What is the data structure of the array? Here also growable array. What is the data structure of the stack? Last in, first out. Last in, first out. What is the data structure of the hash set? It is a hash table. What is the data structure of the linked hash set? It is a hash table plus double linked list. What is the data structure of the tree set? It is a binary tree. The data structure of the tree set is a binary tree. What is the capacity of the array list? Default capacity is a 10. What is the capacity of the linked list? It is a, what is the capacity of the linked list, guys? Capacity for the linked list. Linked list capacity 16. Linked list capacity 16. Linked list capacity 16. Capacity will not be there, na? It is a double linked list concept, right? Double linked list concept, na? No capacity, right? Vector ki default capacity 10. For stack, what is the default capacity for the stack? What is the default capacity for the stack? No capacity, because it is a LIFO data structure. For a hash set, what is the capacity? 16. For linked hash set, what is the capacity? 16. For tree set, is there any capacity? For tree set, is there any capacity? No, it is not applicable here. Load factor, not applicable here. Not applicable here. Not applicable here. Not applicable here. For a hash set, what is the load factor? 0.75. For linked hash set, what is the load factor? 0.75. 0.75. Okay. Now, sorted order. Who will maintain the sorted order? Will array list will maintain the sorted order, or array list will not maintain the sorted order? Will array list maintain the sorted order? Array list will not maintain the sorted order. No sorted order. Linked list, no sorted order. Vector, no sorted order. Stack, no sorted order. Hash set, no sorting. Linked hash set, no sorting. This hero will perform sorting. Who is that hero? Tree set will perform the sorting. Tree set will perform the sorting. Understand? Homogeneous data. Who will support homogeneous data? Everybody will support homogeneous except tree set. As a tree set providing the sorting, homogeneous data not supported. As other collections are not performing the sorting, they will support homogeneous data. They will support homogeneous data. Understand my point, all of you? Understand my point, all of you? Comparison. Yeah, for interview perspective, this comparison is very important. For interview purpose, this comparison is very important. Look at this. Array list, linked list, vector, stack, hash set, linked hash set, tree set. Array list, duplicates are allowed. Linked list, duplicates are allowed. Vector, duplicates are allowed. Stack, duplicates allowed. Set based collection, duplicates are not allowed. Insertion order. Everybody will maintain the insertion order except hash set and tree set. Hash set will use the hash table. Insertion order will not be available. Tree set will maintain the sorting order, so insertion order will not be available. Null value. All the objects, all the collections will support the null value, whereas tree set will not support the null value because tree set should perform the comparison to maintain the sorted order. What is the internal data structure of these collections? Array list will maintain array as a data structure. Linked list will maintain double linked list as a data structure. Vector will maintain array as a data structure. Stack will maintain LIFO as a data structure. Hash set will maintain hash table as a data structure. Linked hash set will maintain hash table plus double linked list. Tree set, binary tree will maintain as a data structure. Capacity, 10 array list. Linked list means no capacity because it will maintain the double linked list concept. Vector capacity is 10. Hash set capacity 16. Linked hash set capacity 16. Tree set no capacity because it is a binary tree. Load factor, hash set linked hash set will have a load factor. Sorting technique, no collection will maintain the sorting technique, only tree set will maintain the sorting technique, will maintain the natural sorting order. If it is alphabets, it will sort in the ascending order. If it is alphabets, natural sorting order. If it is numbers, ascending order. Natural sorting order, alphabetical or ascending, these are natural sorting orders, will be maintained by tree set. Tree set supports only homogeneous data. Remaining collections will support heterogeneous data. Which collection will support only homogeneous data? Tree set supports only homogeneous data. What about the remaining collections? What about the remaining collections? They will support both homogeneous and heterogeneous. Are you clear? You got the full picture of, you got the full picture. Now let us compare cursors. Okay, what are the cursors we have? Iterator is one cursor. List iterator is one cursor. Enumeration is one cursor. Iterator, list iterator, and enumeration. Okay, guys. Now, if you go for iterator, forward direction and backward direction, list support, set support, list support and set support, and removing the objects while iterating the collection. Removing the objects while iterating. Okay, guys. Iterator, list iterator, and enumeration. Okay. Legacy classes, legacy support. We discussed about the cursors. What is the purpose of the cursors? Cursors are used to traverse the collection. How many cursors we have? There are 3 cursors available. One is iterator, second one is list iterator, third one is enumeration. Iterator, list iterator, and enumeration. There are 3 cursors available. Now, when it comes to this cursor concept, forward direction, will iterator support the forward direction? Iterator will support forward. List iterator also will support the forward. Enumeration also will support the forward. Backward direction, iterator will not support the backward direction. List iterator will support the backward direction. Enumeration will not support the backward direction. List support, iterator will support for the list collection. List iterator also will support for the list collection. Enumeration only for vector and stack. Only for vector and stack. Legacy legacy. Set support. Iterator will support for set. List iterator will not support for the set. Enumeration, no support. Enumeration applied for legacy. Remove, it will support the remove. List iterator will support for the remove. Enumeration, no. Enumeration only iterate, no remove support. Legacy, for legacy classes, enumeration is available. Enumeration is available for the legacy. Understand the cursors. Collections comparison and cursors comparison. Take a photo. Cursors. Iterator, list iterator, enumeration. Guys, forget about the real-time scenarios. First, understand the concept. First, understand the concept. Scenarios we will discuss. Map is there, na? Map also we need to discuss, na? Hash map, linked hash map, tree map. Map concept is there. Okay? Perfect. Good. Thank you, guys.